Good morning, everyone. My name is Vinny Valdez. I'm with the North American Tiger team, focused on OpenStack. My title is an OpenStack Enterprise Architect. I work together with partners and customers and other internal organizations, and our focus is to make sure that customers are successful with OpenStack. So today, I'd like to talk with you a little bit about Neutron Networking. We'll go into a little bit of the under the hood details and walk through some diagrams and talk about how the packets flow between all of the different devices and interfaces. And then we'll go into some troubleshooting methodologies, and we'll close up at the end with some sort of best practices and/or common customer engagement issues that we've run into, at least over here in North America. And I'm hoping to share these, and hopefully they'll be able to help you in your engagements. So that's what we're going to talk about. So we'll start with what I'd like to do is just kind of level set a little bit, talking about Nova Network and Neutron Networking. So you may have heard both of these terms. And so what I've done is I just want to create a quick table to highlight some of the differences. These aren't necessarily trying to say one is better than the other, but really to help people understand why you would make certain choices. So Nova Network is very simple. There's a single agent that runs on either a single host or it can run on the compute nodes themselves. So it makes it fairly simple for deployment, for working out your topology. Whereas Neutron is very complex. As anyone who has worked with it before can tell you, there are a lot of parts. There are a lot of different ways you can put the different parts together, and many, many ways they can all break. There are multiple agents. Some of these agents can either run on the controller or on dedicated nodes, or we'll talk a little bit later about some of the high availability strategies with some of them. But the point here is, there are a lot of parts and there are a lot of components and agents with Neutron. Nova Network has been around since the beginning, so it's a lot more mature, a lot more established. But Neutron is it's maturing is a good way to put it. There are definitely some things that are on ongoing basis trying to be improved, and there are a lot of blueprints for additional features in the future. There's just a lot of work going on around Neutron. But around Nova Network, the work hasn't stopped. So I believe about 9 months ago or so, Nova Network was slated for deprecation. So it was going to be completely replaced by Neutron. But because of some of the issues that have been seen by some of our customers, Nova Network has not been deprecated. It's still under development. It's still open to bug fixes and features. So really, there are two valid options to choose from in terms of networking. So Nova Network only supports a flat topology or a VLAN. It has a VLAN manager that will enable it to use VLANs, whereas Neutron allows a lot more options. So one of the original goals was to cover all the same use cases as Nova Network. So it does cover flat and as well as VLAN, but we now have the ability to use overlay networking. So overlay networking would be tunneling technology. So you can use, for example, GRE or VXLAN tunnels on top of a standard IP network. You also have layer 2 and layer 3 topologies that are possible, as well as SDN. So SDN simply means the ability to separate your control plane from your data plane. So these are all additional features that Neutron brings. The Nova Network does not have any type of plugin system. That's another thing to think about. Whereas Neutron does. There are many third-party plugins available. Many have been certified with RHEL OSP. There are many others out there, Nicira, Cisco, quite a few that are able to plug into Neutron and extend the functionality. I briefly mentioned earlier that Nova Network has the ability to run in what's called multi-host mode, and this allows the Nova Network service itself to run on your compute nodes. So if you can imagine, as you scale out and as you start to increase your compute node and your implementation capacity, it's going to be a lot easier to scale that out with lower complexity if you're going with Nova Network versus Neutron. So there are some scaling concerns. If you think about the topology, the general sort of out-of-the-box configuration is to have a single Neutron server that would run the various L3 agents that we'll talk about in a minute. But as you can imagine, it's not very efficient and not very scalable for many VMs across multiple hypervisors to have to route through one single system. So there are ways to configure it in highly available configuration, but unfortunately, so far that's only been possible in active passive. There is some work going around um, to make that available in an active configuration. We're just not quite there yet. There's some blueprints that the last time I checked were not going to make it into Icehouse. That was looking like something a little bit further out, like maybe Juno. Also, Nova Network doesn't have any sort of as a service offerings. So Neutron has varying degrees of different as a service. So we have load balancer as a service, VPN as a service, and firewall as a service. Those are all on the horizon. I don't know the exact supportability of each of these components with our next release. I believe some of these may be tech preview, some of these may be supported. We're yet to see about those, but the point is that the features are there. They are being worked on. And for example, load balancing as a service, you can very quickly set up an HA proxy load balancer to set up, say multiple web servers behind that. And these are exposed to tenants, so they can very easily set up load balancer pools and front ends. And what's really nice about that is based on the plugin system, you can actually swap that out. So instead of using HA proxy, you could have your load balancer as a service, same API exposed to the tenant, and it could on the back end be configuring some other load balancer, maybe a hardware load balancer, or whoever has certified plugins.
Vinny?
Yes.
Vinny, can you hear me? It looks like it's still on the title slide. Is that correct, or
no,
have we got some issues with the...
All right. So the last thing on this table, I was just kind of going through the differences of Nova Network and Neutron. The last thing I wanted to mention was the no multi-tier topologies under Nova Network. So with Neutron, you do get that ability. And we'll look at some diagrams here next. I'm going to go ahead and move on to the next slide. So this is single flat network. So this is really just representing the absolute basic network, simple topology that you can have. This is supported by Nova Network as well as Neutron. So we're just seeing one network here with several tenants. So the next extension up from this would be a multiple flat network. So again, very simple. 3 different networks all running off one physical router. Tenants have access to various networks just depending on what the administrator is giving them access to. Next would be the mixed and flat network. So mixed, flat, and private. So this would be you have the ability to have multiple networks as well as give one of your tenants a private network if they need it. And I just lost my presentation. All right. After that would be the when you actually give tenants the ability to create routers. So this is where the power of Neutron starts to come in. So you would define an external network, typically, and then off of that external network, it would route down on this diagram. We're looking at a route down to a physical router, and above that we see a provider router. So the provider router in this case is a router that was created. So it's a Neutron layer 3 router. Off of that router, you could then have multiple private networks. So in this example here, these networks can't overlap. So if you notice, we have one network that's a 10.0.0.0, whereas the other one's a 10.0.1.0. So they're both /24s. They are their own disparate private networks, but they're still sharing this one layer 3 router. After that, this is where we get into the real power of Neutron. So very similar to the previous diagram, the difference here is that we have 2 different routers. So tenant A has their own router, and tenant C has their own router. So this is really what customers are looking for. If you notice, this topology does support overlapping networks. So we can have a 10.0.0.1 for tenant A, and we can also have a 10.0.0.1 for tenant C. Now these are completely separate. They'll be encapsulated within network namespaces, so that any of the tenant A virtual machines are not able to interfere with or see anything with the tenant C. Okay, does anybody have any issues so far? Just let me know. Otherwise, I'll move on to the next session, which is talking a little bit about under the hood. Okay, so I'm going to do a lot of talking around some of these slides. I don't have a lot of bullet points. I really wanted to really have more of a conversation and talk through some of these details. We do have This image I took from RDO. We have a very nice page if anyone has not seen it, and I'll include a link to that if anyone's curious. But the title of the article is Networking in Too Much Detail. And it goes into excruciating detail what all of these different bullets and these different lettering packet flows occur and what they mean. This is really a more simplistic kind of overview version of that. So I'm going to talk through just some of the details here. I'm not going to go into every single one, but what we're seeing here is a compute node on the left, and then we have the Neutron networker on the right. So I'm going to start with, we have test 0 in the upper left. This represents an instance. So when an instance wants to communicate, on this diagram, we have the letter A. That represents ETH0 for that instance. So this is the virtual NIC that instance has locally. And that is the only thing it's aware of. I'm not going to go into a lot of detail about floating IPs, but Neutron supports the idea of attaching a floating IP, which is a way that it handles NAT from external to these instances. Now, the instances themselves are not aware of this address. It's very much like the Amazon model, where you have a private IP within one of the instances, but you actually get routed and NATed through some kind of external IP. And so if you were to access that external IP and SSH into, for example, an Amazon instance, then you did an IPA on your system, you'd see that you didn't actually have that IP. Same model here in OpenStack. So a packet would leave out of this ETH0 interface, which is labeled A here, and then it would hit what we see as B. So B is, it's what's called a tap device. So typically it's VNet 0 or VNet 1, and what's connecting to, we see this QBR. You'll notice throughout a lot of the Neutron interfaces and utilities, a lot of things begin with Q, and so that's a holdover from the previous project name, which was Quantum. So this was essentially supposed to be a quantum bridge, and that's why we see QBR. And I'll summarize what these mean in a few slides, but essentially, this is what's known as the firewall bridge. This QBR here is where Iptables is used to assign essentially what are known as a security group. So these are just various rules for that specific instance. And you notice this instance has its own specific tap device. So if we were to look on a Neutron network server or a compute node, we would see various devices that correspond to all the different instances. Okay, so then once we get to C, the other end of this this QBR, this bridge, this is what's known as a VETH pair. So this will be labeled as QVB if you're looking at one of your hosts, either compute host. You'd see this QVB. So the QVB stands for a VETH pair that's touching the bridge side. So that's what C is. D is QVO. So you'll see the QVB and the QVO. Those are what are known as a VETH pair. So the O signifies that it's touching the Ipv6 side, which is this BR-int that we see below it. So BR-int stands for internal bridge. So it is it's an Ipv6 bridge that will handle translating and tagging packets internally. Now, these are completely separate from whatever mechanism you're using to route the traffic, whether it was Gre Tunnels or VLAN. A BR-int will perform some Ipv6. It's actually OpenFlow rules that are used to actually translate those. So then when we hit E, we go to the BR ton. So this is the GRE. In this case, we're looking at an example of a GRE configuration. The packet now leaves the BR-int, the internal bridge, and goes to the actual tunnel interface. And so this tunnel interface is where there's another translation that occurs between the actual VLAN ID side, which is what Ipv6 added to it, to whatever the technology is. In this case, it's going to be a tunnel. Once we're done with the translation and we have this BR tunnel, then it finally leaves the compute host and goes over to the Neutron host. So that's represented by this dotted dashed line between G and H. And once we get to the Neutron host, we're basically traversing the stack the other way. So we have the same BR ton that was created for the GRE tunnel. This is the Neutron side of it. Those packets then go to another BR-int. This time, this one's on the Neutron host. and those get translated according to the same rules once again. This time, the intention here is that they're going to either route out, or if we imagine a DHCP discover series of packets going back and forth, when it hits this BR int, it's going to broadcast and do a discover, and there is a DHCP agent that's running that we see on O and P here, that will actually respond to the client request and send that back. And as it goes back up the stack, it gets translated properly and responded to correctly on, in this case, it would be test 0. And then once, if that packet needs to go out, it would then hit the L3 router between M and N we see here, and then it would leave via, typically we have a device called BREX. So people who have been working with Neutron may have seen that before. It's a default in the Neutron configuration to use that bridge as your external router. I'm sorry, as your interface to route the packets externally. And so that's why we see it connected to this little cloud image. The one thing is, if you end up using Foreman or PackStack to do your deployments, the one thing not completed in terms of configuration would be BREX. So although it is the default and it is expected that it be in place on the system, that is the one thing that has to be done manually. So if you're new at deploying OpenStack and you thought you got everything running, but you're not able to route outside, just make sure that you have the BREX configured. Okay, so I'm going to move on to the next slide. This one is a lot more detailed, compute node representation. So these diagrams I borrowed from upstream OpenStack. There's a lot of detail if you're interested. I'm not going to go through every one of these components. This is basically more detail than what we just went through. But this shows basically the same thing. So we have 3 virtual machines. We have them, they have their own individual tap devices that we see with QBR XXX, QBR YYY, and so forth. And they go down to the same thing, in this case, BR int. And then the one thing different between the previous diagram and what we're looking at now is that now we have a BR ETH at the bottom. And so that's just a standard bridge that's created instead of BR. Obviously, we're on the compute node, so we don't have to deal with BREX. But if we go to the next slide, this is where we see the network node. I'm sorry. My point was, instead of BR tunnel, we have BR ETH1. And the reason for that is the previous diagram was using Gre Tunnels. These diagrams here are talking about a VLAN configuration. But I wanted to include these to show that the same topologies are true, whether you're using VLAN for the tenants or GRE or VXLAN. Very similar. It's just how the technology is, how the OpenFlow rules are implemented and translated. Okay. So the next slide I have, it basically tells you what these different acronym letters mean. So I mentioned QVO is the VETH pair on the Open vSwitch side, QVB, same the other part of this pair on the bridge side, QBR, and then you also notice a QR and a QG. So these are the L3 agent managed ports, whether they're on the router side or the gateway side. Okay, any questions before we move on to the troubleshooting? I see some chat questions, but if I click on it, it might make my sharing go away. Please let me know. I'm not sure if anybody is able to see the sharing or not. Okay, so this next section is some tips and tricks on troubleshooting. So I wish I could go through a live demo. It might be a lot more helpful. If anybody has questions or is curious about working with a live system, I'm happy to work with you. But because there are so many different things, I don't think we have enough time to cover it. But I just wanted to kind of touch on some of the methodologies that I've used and other people on my team have used. In fact, I just returned from an on-site with a customer where I was able to kind of refer back to this and say, just make sure I wasn't missing any steps here for this presentation. But essentially what I do, and there's obviously so many different parts, there are a lot of different ways to approach this, but I would start with basic connectivity. So we're assuming at this point that OpenStack has been installed, it's been configured, and we have brought up an instance. And one of the most common or I guess first things you try to do once you get the instance up is, right, let's ping it or let's SSH to it. Is it up? Do I have connectivity? So those tools, very basic but very useful. You also want to make sure that you have the appropriate security group rules established so that you can allow ICMP, for example, or SSH port 22 through. After that, I like to check DHCP on the instance. A double check. If I'm not able to ping or SSH to the IP address I think it should have, then I'll bring up the console. So I'll bring up the VNC console, take a look. One of your first clues would be the host name. So if you have the host name of localhost, then you did not get a DHCP address, which would have given you whatever name you assigned the VM when you did a Nova boot or when you did it from the Horizon UI. Whatever name you use for that instance should be the host name that it has. So without even logging in, just pulling up VNC and taking a look at the login prompt, that will tell you right away. If you see localhost, then you know things are not good. And so I'll go into a couple of slides about my preferred method of checking DHCP. But one of the things, if you use the default cloud image available in the RH Common channel, it's a Rel 6 guest image that you can upload. There's no password set on it by default, so you would have to typically boot into single user mode and reset the password if you can't SSH. So kind of keep that in mind. There are ways to open up that image and modify the password and things like that, but generally working with customers, I'll have them do a yum install of the Rel guest image 6 and try to use that right off without any modifications. The other thing would be review logs. I know it sounds kind of cliche, it sounds kind of basic, but you'd be surprised how many times I've been involved with critical situations that, we'll ask the questions, well, what's the actual error in the logs? And you usually hear, if someone says, let me look. And then you typically will look and see a big traceback that will give you a big clue as to what might be wrong. After that, after I look in the logs, I typically like to tail the logs and follow them and then bring up the instance or do some other action that will cause Nova and Neutron to work together and try to get the instance up. And you can usually generate whatever errors you're looking for. After that, I start to follow the packets. So this would be where tools like Wireshark or Tcp Dump are going to be very, very invaluable. And of course, understanding the topology, understanding how all of the components work together, like we just talked about, will help you understand where you need to look next. So if you're following packets and they leave, for example, a very simple example is you want DHCP on the instance. So you can TCP dump on the compute node, and you would want to start closest to the instance, right? The instance is not getting an IP, so we know how DHCP works. We know that there's a discovery process and an offer. So we know packets are, or hopefully at the most basic level, packets are leaving the instance and going through that tap device that we talked about. From there, it goes to the BRE and internal. From there, it goes to either your tunnel device or whatever tenant technology device that you're using, whether it's VLAN or GRE or VXLAN. It goes there next. So knowing that information will help you. So I would typically start at the tap device and TCP dump. Do I see the DHCP packets coming out? Yes. Okay, let's move up the stack. Let's go and look at BRInt, and then and just continue moving down that path. And in a lot of cases, you'll end up finding, for example, the packets are leaving the compute node, but they're never getting to the network node. So then next thing, are we using VLAN? Yes. Is the switch configured? And that's something I've seen a lot in the past, especially around VLAN for the tenant networks, is switch configuration problems. Okay, I think I mentioned briefly that there's a network namespace that separates all of the different tenant networks. So one of the things you want to do is operate inside the tenant namespace, and I'll show an example of how to do that here in a second. And then finally, after you've done a lot of this troubleshooting, then you want to start looking at the Open vSwitch configuration and the OpenStack configuration. One of the things I will stress, and I've done this a lot of times to myself, is it's really easy to maybe Google a problem or maybe try to tweak something real quick in the config file, make some changes, restart some things, make some more changes, and then before you know it, you've really lost track of what you've changed. So I'd recommend using the OpenStack config command so you can have a history in your bash of what you've done, or just be very diligent about backing up files and commenting out changes. Okay, so going through some of the things we talked about in the previous list, one of the things I would say is once you've gone to the VNC console, let's say you see localhost, and you want to basically get in and start generating DHCP traffic so you can start TCP dumping or Wiresharking and try to figure out what's going on. So if you go to the VNC console, you'll see this little send control delete icon in the top right. If you go ahead and hit that, cause your virtual machine to reboot. And if you'll notice, and this is true of any QEMU virtual machine, works in KVM as well, you'll see this gPXE prompt come up very quickly. You probably have 1 to 2 seconds to notice this. So you're gonna have to click in there, 5 or 6 times as rapidly as you can, and then try to hit Control B. And if it doesn't work, you might want to open the VNC console in a dedicated tab, so it's not the Horizon integrated version. But eventually you'll get there. So if you miss it, just hit Control Delete again, and hit Control B. If you did it right, you should get a gPXE boot prompt, or essentially what seems to be like an input prompt. From there, you can type help. You can see what options are available. But what I like to do is just do auto boot. So auto boot will find the first network device, and in the case of these virtual machine, these instances, they're typically just one device unless you've added multiple. But auto boot will start generating a DHCP discover and start generating traffic. So I find that to be simple because you can just do that without even being in the OS at all. We're just essentially at hardware level here, or virtual hardware, and generating DHCP traffic. So the logs themselves, what I like to do is I like to tail-f on varlog neutron start.log and varlog nova start.log. So I'll do this on the controller and the compute node. If you have a dedicated neutron node, you would only have the neutron directory, not nova. But if you run this on as many of the components involved as possible, and then as I mentioned, just start up an instance and watch these logs. If you find the logs are too noisy, you may have to pipe them into a grep -I error. That'd be a good way to kind of filter out all of the debugging information and get to just what you're looking for. So the next slide just gives a quick example of a TCP dump I like. If you use the -E option, which I didn't use in this example, you also get some additional layer 2 headers information within the dumps themselves. But this gives you an example. I'm TCP dumping on this one part of the VETH pair on this BR ETH1 that I have set up, and I'm just looking for boot PS packets. And so we can see here that one host is trying to send out some UDP packets. So other commands that are helpful, ipNetNS. So the netNS subcommand to IP will give you a view of the different namespaces. So typically when you have one tenant, you'll see a Q router UUID as well as a Q DHCP. So what you can do is you can do an ipNetNS exec against that ID. So just copy and paste it. And once you've done this first, these first 4 commands, which is ipNetNS exec and then an ID, you could then do any normal command after that within the namespace. Like you could do another IPA to look at what IP addresses are assigned to that within that namespace, or you could even do a TCP dump within that namespace. The one thing you want to do though, for example, let's say we're starting out and we want to TCP dump on the tap interface within the namespace. So you would do the ipNetNS exec, the Q router ID, TCP dump, whatever command options you like, but you want to make sure and do a -L, which will allow you to instantly see the buffer as it's happening within the namespace. Otherwise, you won't see it until you hit Control-C. It'll all like dump out at once. Other good commands would be OVS, which is Open vSwitch, VSCTL show, and then also OVS OF CTL dump flows on a bridge. So the first command will give you the configuration of Open vSwitch on that host, and the second one will actually dump the open flow rules, so you can take a look at. This will help you understand the mapping between the packets for a particular router or tenant, and how they map or translate to the VLAN ID that OpenFlow has translated. Okay, so this slide here, I didn't title it here, but this is essentially a way to mirror a port and send all of your different interfaces to it so that you can kind of monitor it. So this is useful if you're trying to figure out where a packet may be falling down and you want to monitor all your interfaces at once. Okay. So the last section here, I just want to talk about some common issues I've seen. So these have actually hit us at a few customers for various reasons. And what's interesting, it really all comes back to a customer's standard build or standard operating environment. One of the things that we've tried to stress with customers is that OpenStack, our RHEL OpenStack platform is tied very tightly to Red Hat Enterprise Linux. So it's not a layered product. It's not something that you can throw on to your standard customer build. And it's part of that is messaging, but part of that is reality because customers are used to their builds. They've eliminated certain software that they feel is not right for whatever reason. And in many cases, that's not the right thing for OpenStack. Go through some of these examples. So NTP, I listed here because it's probably the number one thing that we see when we get any kind of issues with the message system. So I just wanted to stress that. Always set up NTP. I'm hoping everybody does anyway. But even if you can't set up an internal server, just make sure you can get everything in sync, even if the time is wrong. Just they should all be wrong the same way, or you will just have bad times. So IP link is something else. If you are using VLAN for the tenant networks, you would typically have a dedicated Ethernet device. Let's say ETH1, for example. You would want to make sure that the link to that device is up. So you want the boot proto to be, well, could be off or none for the boot proto, but you want it to be on boot in terms of the configuration. That's one of the most common things I've seen when using VLAN for the tenant networks is that they specify ETH1, but since you don't want to have an IP assigned to it, there's no link. It's down, and Neutron can't build all of the interfaces it needs. So, okay, these last four are things that have been a result of customers' corporate images not having these different services turned on. First of all would be sudo. So Nova, Cinder, Neutron, and I believe those are the main three, all use sudo to perform various commands. Part of it is during the initial setup, but there are regular commands when you just start services that are executed via a root wrap script. And so I've seen at least 3 customers I've dealt with that didn't have sudo for whatever reason. And it's pretty obvious to look in the logs, and you'll see the sudo commands that are trying to get run. So if that fails, there'll immediately be a traceback, and that'll let you know. But there are definitely customers that, for whatever security reasons, have other software that performs the same thing as sudo. We've been able to get some of that to work. The main thing would be that whatever commands are failing need to be able to run somehow. The other thing is Iptables. So we talked about the tap device, about how that's used for security group rules, which are very heavily dependent on Iptables. So we have customers that turn it off. Well, for OpenStack, it needs to be on. It has to be check config on, and the service has to be started. One thing I will caution, though, is make sure that you're not using Lockit. If anybody's familiar with that, it's a nice little shortcut utility. I like it. It's great. It's a very good, quick way to get a port or two opened. The problem is if you run Lockit on a system that has OpenStack installed, it'll wipe out all of its rules. So you don't want to do that. There are a lot of custom rules that get created for Neutron and by Neutron and Open vSwitch. So you want to make sure those are enabled. Ipv6 tables also has to be on. So there is a bug I found in which if you have Ipv6 tables, if you have Ipv6 disabled, Ipv6 tables is not able to start because it can't find the Ipv6 module to load. So it's interesting. Neutron doesn't yet support Ipv6, but it needs to have it enabled or it will fail. So that's an odd one that I've seen. So here's an example, just to see what the sudo error would look like. So we're looking at varlog neutron open vswitch-agent.log, which, by the way, is probably where most of your common errors are going to be logged on any of your systems, whether it's the Neutron agent server or the actual compute node. But so here there's an error. You can see that it's actually tells you exactly what it's trying to connect. Trying to execute. So unable to execute, and it tells you the command exactly in a little bit of an array here. You know, OVS vsctl -- timeout get interface, so on and so forth. So in this case, it tells you the command again. Well, there's a command after that. This is sudo using the Neutron root wrap, and so on. So this is one incarnation of sudo being disabled. If you enable it, and in our case, we did enable it, we were able to get a little bit further along, but we were running into some additional issues. So the next slide talks about the Ipv6 support. So there's an article I included here that gives you specific details on how to go through on the system, make sure Ipv6 is enabled. You have to look in sysctl.conf. There's a couple of settings in there, as well as looking in etc modprobe.d/Ipv6. If it was disabled, maybe during install or something, you'll see that. You can always cat procnet if_inet6, and that will tell you if it's enabled. Another good way, you could also do lsmod, pipe into grep Ipv6 something, can't remember exactly. But if you just run Ipv6 tables -L, so that should give you some output with the word neutron in it a lot. So you should see a bunch of neutron rules that were created. If you run if you run that command and you get a failure, then the next slide shows an example of that. So if I look in the logs, you'll see a similar sudo neutron root wrap command trying to get run. And a couple of lines later, you get an error that it was not able to. If you look at the details, it says unable to initialize table filter, and there's a little bit more detail below that. But if you try to run that command manually, that's what I'd recommend. If you see some errors in the logs like this, you know, trying to execute some command and it's failing, just run that and see what happens. So in this case, I ran sudo neutron root wrap, the rest of the options, and I get this unable to initialize Ipv6 table filter. So this is basically telling you Ipv6 is not enabled. So with that, I think that kind of wraps up what I had to share. I see that we have about 15 minutes left, so I'd like to open it up to any questions. I know I did a lot of talking. I hope that wasn't too boring. Can anybody hear me? Absolutely, yeah. I didn't talk about that, but in the last two asynchronous releases of RHEL OSP, so we just saw the async 4 release a couple of weeks ago. If anyone is not familiar with that, please do look up. There's an OpenStack release calendar internally that we can access. It'll tell you exactly when the async releases are. But starting with async 3, support for ML2 was added. So ML2 stands for Modular Layer 2. And what it is it's a plugin. Instead of when you initially set up OpenStack, in the past, you would pick what your plugin technology is that you're going to use. So you may pick Open vSwitch, or you might pick Linux Bridge, or you might pick something else like Nicira or something else. Well, now with the addition of ML2, you would pick ML2 as your plugin, and then ML2 takes what are called mechanism drivers. So now you can enable multiple backends this way. So you can enable Linux Bridge as a mechanism driver, as well as Open vSwitch, as well as Nicira and whatever else. Well, actually, I don't know if there's a Nicira ML2 plugin, but anything that has an ML2 mechanism driver support, you can enable that. You can also enable multiple technologies. So you can have VLAN and GRE for tenant networks instead of just one. So that's what ML2 is. It allows you to have the modular plugins enabled. don't know if it's appropriate, but if we don't have any specific questions, I guess I'm curious if anyone um, has opinions on Neutron versus Nova or any questions about that. So I did cover at the very beginning. There's a table in the slide deck, and I'll make sure that everybody has that. But these are kind of a summary of the differences between Nova Network and Neutron. I think it's kind of arguable which one's better. I think if you ask a Neutron developer, they'll tell you Neutron's better. Um, and the other way around probably. But in general, the differences are basically, Nova Network's been around a little bit longer, a little bit more mature, but it supports less features. But it does scale a little bit better, and probably under a highly available configuration, it'll probably be a lot easier to get Nova Network to work than it would be Neutron at this point, but that's being worked on. Okay, let me see if I can get to these. Regarding security groups, we're getting rid of the QBR. So the question is, are we getting rid of it? So that QBR is referred to as the firewalling bridge because it is where all the security groups happen. So were you asking if we were going to get rid of it? Not that I'm aware of. I know there was in the manual, if you look in the upstream networking administration guide, it talks about how the instances ideally would be connected directly to BRINT, but it has something to do with the way Open supports Iptables is why they had to do that. It's kind of like a workaround. I think, Glenn, that's a good idea. A debugging guide would be very helpful. Okay. I have not. I'm actually, so anyone interested, if you have access to Coursera, coursera.org, I believe, there is a free SDN class going on, software defined networking class by Georgia Institute. And they're covering all OpenFlow and a little bit of Open Daylight and everything from an SDN perspective. I'm actually going through that class, so I'm still learning myself. So Neutron HA. So today, the HA story around Neutron is that it's active passive for so the server itself is the API service that can be active as with most of the API services. But when we talk about the L3 agent, the DHCP agent, and the metadata agent, which are three of the agents used for Neutron, I believe you can have multiple DHCP agents without much issue, but the L3 agent and the metadata agent don't currently run in active. So it's basically a combination of active and active passive. But I know there's a lot of work that went on, and I'll have to double check. I believe some of that might have made it into A4 release, but I wasn't exactly sure. But there was some work going on to enable active all the way around in Neutron, and I know they're targeting that for the next release. So I'm not the best person to ask about what we're doing with Open Daylight. I know it's really on the early edges of the technology. I don't know when it would make into a product yet, but I will try and find that out because that's something very interesting. I really don't know what we're doing with Open Daylight yet. I've heard we've been working with them a lot, but working with that community, but I don't know where we are in a official product standpoint. Hmm. Yeah, I would agree. There's a little bit of overhead involved. Oh, sorry, Richard. Yep, I did miss yours. Um, I don't know what the exact answer is for that because we've deployed Cupid in about probably 4 different ways so far, and I know engineering is kind of uh, going through some additional testing to determine the best tuning parameters for Cupid. I don't think we have that information yet. I know that they're looking at, or they will be adding RabbitMQ as an option uh, in Icehouse. So we've been asking the same question, and I don't think we have a good best practice number for tuning Cupid in general. Oh, thanks, Glenn. But, I heard load balancing as a service and firewall as a service would be tech preview as well. Trove should be a tech preview. Sounds like Open Daylight. That would be great. I'll try to find the official list. Hmm. I thought that LBAS was not yet supported. Okay, I'll find out. Yeah, NFV is really huge. We're working with some telecom vendors, and their NFV use cases really stretch our Neutron knowledge. So yeah, it's good to be working in that space. Hmm. One of the other things I guess I would just kind of share with you guys is we have done some work with vCenter in terms of VMware on the back end for a hypervisor using NSX as the networking layer. And there's not a lot of instructions out there. I mean, we do have an article that talks about some of the integration, but there's a lot of stuff on the VMware side that they have to do, and we don't really have a good feel for that. So we have to kind of depend on VMware when they configure their NSX clusters. But yeah, that's been something we've had to go back and forth with VMware on. Sure. See if I can find it. Yes, I would. Here we go. This is the one we've used. Yeah, full overlay networking is killer. Well, there's only a couple of minutes left. Do we have a Mr. Moderator who'd like to say any words? Mr. Track C? Or is there anything else I can help with? I wish I would have been able to do some live troubleshooting. It was just didn't seem like I had enough time. I'm thinking about maybe doing a screencast to share some of these. I don't know if that would be helpful. It definitely does seem to be any neutron type issue does seem to be the biggest time consuming problem that we run into. I haven't tried Elasticsearch. Thank you, everyone. I appreciate it. Enjoy the rest of the day.